Okay, so let's go ahead and prove the derivative for f of x is equal to a to the power of x today, where a is any number greater than 0 and not equal to 1. Okay, so the claim, okay, is if f of x is equal to a to the power of x, then f prime of x is equal to a to the x times the natural log of a. Okay, and this, of course, is for a not equal to 1 and a greater than 0. Okay, okay, let's go ahead and prove this derivative statement today. Okay, using the definition of the derivative, that's how we do this. F prime of x is going to be equal to the limit as h trends to 0, okay, of a to the x plus h minus a to the x all over h. Okay. Okay, well, this is going to be the same thing as the limit as h trends to 0 of a to the x times a to the h minus a to the x over h. Okay, using the property that if you have a to the x and you multiply it by a to the y, that's the same thing as a to the x plus y power. Okay, that's an exponent property that we're using right here. All right, very good. Well, we can clearly factor an a to the x out of both terms here. So this is going to give us the limit as h trends to 0 of a to the x times the quantity a to the h minus 1, all of that divided by h. Okay. All right. Well, we can see here that the limit is dependent on h. It's not dependent on a or x. So we can actually take this a to the x factor out, and we can write this as a to the x times the limit as h trends to 0 of a to the h minus 1 over h. Okay. So what we ultimately want is, because we have an a to the x here, we want all of this to be equal to the natural log of a. Okay. So what I'm going to do is use a substitution here. Okay, we're going to let u equal a to the h minus 1. Okay. All right, if u is equal to a to the h minus 1, that means that u plus 1 is equal to a to the h. It also means that the natural log of u plus 1 is equal to the natural log of a to the h. And that means that the natural log of u plus 1 is going to be equal to h times the natural log of a. Okay, using the power rule for logs, which I've proven in a previous video. Okay, very good. Now, if I want, I can solve for h. I can write this as h is equal to the natural log of the quantity u plus 1 over the natural log of a. Might not need that, but let's keep that handy just in case. Now the limit as h trends to 0 of a to the h minus 1, okay, is 0, okay, because as h goes to 0, a to the 0 is 1, right? As h goes to 0, a to the h goes to 1, and 1 minus 1 is 0. But that's the same thing as the limit as u goes to 0 of u, okay? Okay, good. All right, let's go ahead and go back here. We have a to the x. Now we're going to choose to use the limit as u trends to 0 of, okay, and replacing a to the h minus 1 with what we know it is, u, okay, and then replacing h with this, and that's going to be the natural log of u plus 1 over the natural log of a, okay. Put some brackets around that there. All right. Well, that's the same thing as, why don't we zoom out maybe one step here. That's going to be the same thing as a to the x times the limit as u trends to 0 of u ln a over ln of u plus 1. Okay. Again, when you take a number and you divide it by a fraction, it's the same thing as taking that number and multiplying it by the reciprocal of the fraction. Now, the limit is dependent upon u. It's not dependent on a. ln of a is a constant. We can actually take ln a out, and just like we have a to the x out, okay, and we can write this as follows: a to the x ln a, which, by the way, it's kind of what we're looking for here, right? Times the limit as u trends to 0 of u over ln of u plus 1. Okay. We want this to be 1, don't we? And it is 1. Okay, it is 1. This is one of these limits that we can readily determine as 1. I'll prove it using a graphical argument here. Why don't we call this u? Okay, u-axis, and then y. Okay, what is y equals u look like? Well, that's just the line going through the origin. Okay, so we'll call this y1 is equal to u. Okay. All right, what does the natural log of u plus 1 look like? Well, the natural log of u is just going to be here with a vertical asymptote at x equals 0, right along the y-axis. The natural log of u plus 1 is just going to be that shifted over by 1 unit to the left. So I'm going to shift that vertical asymptote over here. So this is the asymptote u equals -1. Okay, keeping in mind this is the u-axis, this is the y-axis. And if I let u equal 0, I have the natural log of 1, which is 0. So it's actually going to be defined right here, and it's going to come up like so. Okay, so this right here, we'll call it y2 is equal to ln of u plus 1. Okay. All right. Well, let's take a look at what happens here. Okay. I'm going to analyze what's going on right here. Okay. As u approaches 0, okay, from the left or the right, okay, y1 and y2 both approach 0. Okay. And since the limit's not concerned with what happens at, but what happens near, notice the slope of the tangent line to this curve at 0 is going to be just 1. Just like the slope of this line is 1. Okay. So as u goes to 0, y1 and y2 both approach 0. Okay. At a rate of, okay, we'll say d du equals 1. Okay, hence, okay, let's maybe zoom out one step here. Hence, d du of y of 1 equals d du of y of 2. And the ratio, well, I should say the limit as u goes to 0 of the ratio, okay, y1 over y2 is 1. Remember, the derivative is, or excuse me, the limit is not concerned with what happens at, but what happens near as we want. I can let both y1 and y2 get as close to 0 as I want. There will always be a definable neighborhood around here. You think about zooming in as much as you want, and the more you zoom in, the more indistinguishable these two graphs are going to be from these two curves, y1 and y2 are going to be from each other. So this whole thing here is 1, right? And there's a geometric or a diagrammatical argument. That's important to see that if you haven't seen that yet. So this whole thing is 1. So there we go. We got through it. I'm sure there's another way we could have done that. I'm sure there are many ways we can do that, but there you go. Let me know if you have any questions, comments, and concerns. I hope you found this video to be interesting and hopefully enlightening. It's important to understand not only how mathematics works, but why it works. Have a great rest of your day, and we will see you in the next video.